Hello class, my name is Wallace, and I am in the United States Navy. I am a Master at Arms, which is military police, and I am proud of what I do every day. I am in Intro to Physics, and let's start learning. When we look at this lab, we will learn about reflection and refraction of light. When we start this lab, we will start with part 1, which is air to water. Our medium 1 is air, and the index of refraction equals 1.0003, and our medium 2 is water, and the index of refraction equals 1.33. To start off our experiment, we will hit go, and we will watch our light reflect. And as you can see, we have 65 degrees for angle of incident, 65 degrees of angle of reflection, and 43 degrees for angle of refraction. For our second time, we will move our light source, and we will hit go to get a different measurement, and we will get 85 degrees for angle of incident, 85 degrees angle of reflection, and we will get 47 degrees of angle of refraction. For our third time, we moved around, and we will hit go, and as you can see, we get 52 degrees angle of incidence, 52 degrees angle of reflection, and we get 33 degrees angle of refraction. As you can see, light travels faster through our medium 1, which is air, and it slows down into the second medium, which is water. For part 2, we change the top to water and the bottom to air, which medium 1, water, is the index of refraction is 1.33, and the medium 2 is air, and the index of refraction equals 1.003. With our new mediums, we will hit go and watch the light move, which we get 65 degrees for angle of incidence, 65 degrees for angle of reflection, and we get 0 degrees for angle of refraction. Once we move our light around, we will hit go and watch it move, and we will get 35 degrees for angle of incidence, 35 degrees for angle of reflection, and 50 degrees for angle of refraction. We will move our light once more, and we will hit go and watch it reflect, which we get 45 degrees for angle of incidence, 45 degrees angle of reflection, and we will get 71 degrees angle of refraction. With these two new mediums, you could tell that medium 1 is water that causes light to travel slower than medium 2, which is air, to travel faster. This material tells us that the incident angle came from a more dense material to less optically dense material. For part 3, we change the top medium to water and the bottom medium to oil, which for medium 1, the index of refraction is 1.33, and medium 2 for oil is index of refraction is 1.47. We will move our light, and we will hit go, and we will watch the light reflect, and we will see that we get 75 degrees for angle of incidence, 75 degrees for angle of reflection, and we get a 54 degrees angle of refraction. Once we move our light, we will hit go, and we will watch our light reflect, and we will get 34 degrees angle of incidence, 34 degrees angle of reflection, and 29 degrees angle of refraction. Once again, we will move our light, and we will hit go, and we will watch our light reflect, and you will see that we get 60 degrees angle of incidence, 60 degrees angle of reflection, and we will get a 50 degrees angle of refraction. As you can see in our experiments in part 3, you could tell light travels faster through water than oil. This material tells us that our incidence came from a less dense to more optically dense material. In our experiment part 4, we changed the top medium to diamond and the bottom medium to air. The medium 1 index of refraction is 2.42, and medium 2 index of refraction is 1.003. Once we move our light, we will press go, and we will watch our light reflect, and you can see that our angle of incidence is 75 degrees, our angle of reflection is 75 degrees, and our angle of refraction is 0. Once we move our light again, we will press go, and we will watch our light reflect, and we will get angle of incidence is 19 degrees, angle of reflection is 19 degrees, and angle of refraction is 52 degrees. Once we move our light once more, we will press go, and you can see that we get 13 degrees angle of incidence, 13 degrees of reflection, and 31 degrees of refraction. As you could tell in part 4 in our experiment, that in medium 1 is the diamond moves more slower and is more dense than our medium 2 is air. This tells us about our material that diamond is more dense than air. Once we get our information, we will plug it in, and we will get 1 sine 49 equals N2 sine 24, and we want N2 by its side, so we will divide both sides by sine 24, and we will get an answer of 1.856, which the closest to that is zircon, which is 1.92. In conclusion to this lab, we were able to explore the properties of reflection and refraction of light as a ray of light travels between the two transparent mediums.